two-value equation, we set up and solve two equations individually. So as an example, if I had the absolute value of blah equals, we'll say 5, I know on a number line that blah can either be 5 spaces to the right of 0, so I would say is equal to 5, but I also know it can be 5 spaces to the left of 0, so I know blah can be equal to -5. And that's why we get the two solutions generally. Okay, so as I said, this lesson is going to be all about isolating the absolute value expression for us. That means get it alone. Get it alone. Absolute value wants to be a loner. Okay, once we do that, then we can move on with the process that we've already learned of setting up the two equations and solving accordingly. Okay, so let's get started. You look at our first absolute value expression, you notice it's not alone. It has -5 occurring on the outside. So if we were to treat this like a variable or like a variable term, let's say it's a 2x minus 5. So as an example, let's take a similar equation. 2x, we'll say -5 equals 21. Well, we would add 5 to both sides, wouldn't we? And we would get this isolated. Okay, we would get the variable term isolated. 2x would equal 26, and then we just move on from there. Okay, so we're going to do the same thing here. We're going to add 5, and we're going to get absolute value of x plus 4 is equal to 26. And from here, we are now isolated. This is the expression with the absolute value we're looking to get on our own. So now we're ready to say, or to acknowledge that, that x plus 4, get rid of the bars, it's always an easy mistake to make. The expression that we're finding the absolute value of, x plus 4, is either equal to -26 because it's that far away to the left of 0, or x plus 4 is equal to 26 because we recognize that it can be 26 spaces to the right of 0. So if we solve through on each, in both cases we subtract 4. So let's get this one out of the way. We say x is equal to -30. And then if we subtract 4 on the other equation we've set up and solved, we should see that x is equal to 22. Those would be our two solutions. So if we do a quick check, I'll actually I'm going to just quickly check over here. And what I'm going to do is erase all this. It's just getting in my way. Okay, so let's do a quick check. So if I do the check of -30, I have the absolute value of -30 plus 4. That once I find that, I'll have to subtract 5 from, and I'll have to see if it equals 21. Well, absolute value, let's see, -30 plus 4 is -26. That I'll find the absolute value of. The absolute value of -26 is 26. That I'll subtract 5 from. And then 26 minus 5, 21 equals 21. So I should be happy with that solution. The other solution, I'll take absolute value of 22. Of 22 plus 4. Once I take 5 away, I should get 21. Well, let's see, 22 plus 4, that's 26, which we'll find the absolute value of. Absolute value of 26 is 26, which when I take 5 away, gives me 21, which is equal to 21. So both of those solutions are true. All right, so let's go on and do the next one. So the next one's a little trickier. I have some addition, which I'll have to use the inverse operation of to solve. And then I have some multiplication that I'll have to use the inverse operation of to solve. So here I'll have to subtract. Here I'll have to divide. Now, one really important point that I need to emphasize, this 2 being on the outside of the absolute value bars, I cannot distribute in the same way as if these were parentheses. So treat this like it's a variable or like a variable term and just get it alone. So let's move on to solving. So subtract 7. 2 times the absolute value, 2x minus 3, is equal to 8. Again, think of this as if it's a variable. So the next thing I need to do to isolate it is to get rid of this 2 right here. So if I divide by 2, I'm dividing everything by 2. This cancels, but remember 8 divided by 4 is also 2. So I'm just going to push this over here. I'm going to say the absolute value of 2x minus 3 is equal to 4. I am isolated. I am isolated. I'm happy. I'm isolated. That's all alone. So we're ready to pick up where we left off with the earlier lesson. We can now say that this expression, 2x minus 3, is either 4 to the left of 0, thus equal to negative 4, or this expression, 2x minus 3, is 4 to the right of 0, so it's equal to 4. Whoops, is equal to 4. I don't know why I have 5 in my head. Now we can go about solving for each. So let's do the first equation. Add 3 to both sides. 2x equals negative 1. Divide everything by 2, and x equals negative 1/2. So we're cruising right along because we should be really comfortable with solving at this point, okay? On the other side, 2x minus 3 equals 4. Well, we isolate the variable term. Here's that whole idea of isolating. So I get 2x equals 7. Divide by 2. Notice I can show, instead of showing everything divided by 2, just show each side divided by 2. Sometimes that's a little less confusing. And I get x equals 7 over 2. And this is okay as an improper fraction as well. We're perfectly fine with that, okay? So if we checked on both of those, and I'll spare you the trouble, but if we checked on both of those, if we substituted negative 1/2 in, multiplied it by 2, subtracted 3, found the absolute value, multiplied it by 2, then added 7, we'd get 15, and likewise we would get the same with the 7/2. So there are your two worked out absolute value equations in